Welcome to MathSolve. In this video, we are going to see how to convert polar coordinates to Cartesian coordinate. And as you know already, in my previous video, I already explained how to plot the polar points and Cartesian points. And here I would like to remind you guys that when you have a XY plane, you have a, let's say this is our x-axis, this is our y-axis, and you have a point which is locating here, but in Cartesian coordinate we say it's x and y because it's going horizontal direction by x, and if you make a vertical line here it's a y. Okay, but when we are saying that point is actually moving along a circle, creating a circular path, and that radius of the circle we are considering as a r, and that's how the polar coordinates come. So polar coordinates is we represent as a r theta. So r is the radius that the circle with of the circle, and theta is the angle creating when it's moving that point, right? So now in this case it is located at a point angle theta. Now r theta is the polar coordinate and xy is known as a Cartesian coordinate. So we are converting polar to Cartesian coordinate, which is x and y. So it means r and theta will be given and we have to find out x and y. And if you look at this uh, diagram here, you can easily make a relation between x, y, r and theta. So for instance, if because we are given only r and theta, right? So what we can do, how to find out x, and how to find out y. If you use cos theta for instance, so if I, because theta is given, so cos theta, and we know that cos theta equal to adjacent over hypotenuse, right? So adjacent over hypotenuse, so x over r, and from here you can see x equal to r cos theta. And same way, if I do sine theta, you can just write down y over r because opposite over hypotenuse, and then in this case y will be, so if I just rearrange it, it would be r sine theta. So it means if I have r and theta given, I can just apply this formula to get x. R and theta given, we can get y. So actually by looking at this diagram we can make the relation between x r and theta and y r and theta, and using this relation to convert it. So let's say we have an example with r is 4 degree, sorry, r is the radius which is 4 and the degree is 135 degree, and the question is asking to convert to the Cartesian coordinate. So again we know that x will be r cos theta. I'm just writing again r cos theta, and then we just plug in the values. So r is 4 in this case, cos of 135, and if you do in calculator, I'm pretty sure you are getting minus 2.8. And then if you do y equal to r sine theta, and again it's a 4 sine of 135, and then you are getting the value of 2.8. 2.8. Okay, so it means the our xy will be, so you can just if I convert it, it will be minus 2.8 as x, and our y will be 2.8, and it is locating in the second quadrant, right? And that if you want to see just is that the second quadrant, yes. So minus 2.8 and then plus 2.8, so it's somewhere here. So somewhere here the point, if it's the x and y. Now also if you look at the polar coordinate 4 and 1.35, 4 positive 4 and 1 positive 4, so it's there, and then 135 degrees, so it's right. So if it's creating 135 degree with the anti-clockwise direction, then we are reaching that point. So that's true, that is the correct answer, so we can check like that. Now, the next one, if I have an example with the negative r, the students often get confused when the r is getting negative. But we don't need to worry about it at all, because we can just apply that formula. So if we have, for example, negative 3 and 60 degree, and we are converting it to the Cartesian coordinate, and again, if I want to get the field where this situated, you can see that negative 3 for r, and then 60 degrees a positive angle, so negative 3 and the positive angle. So if you go positive angle, obviously you have to go with the anti-clockwise direction, right? So it's anti-clockwise direction, so from here to here it is there. So it means you are looking at something in this coordinate. And see, so we are expecting our x will be negative, y also will be negative. That's what it's saying. If we have x and y, you can see that that point is lying negative x and negative y. So let's see, we can get negative x or negative y in this case here. So if we use x equal to r cos theta, I'm not writing the value, I'm just writing r cos of 60 degree. Okay, and if you do that, I'm pretty sure it is for half, so it's a minus 1.5 minus, sorry, minus half, sorry, minus let me just do that, 3 cos 60 degree, which is minus 1.5. Yes, yeah. And then for y, it is minus 3 sine 60 degree. And if I do sine 60 degree, and sorry, sine 60 minus 3 times of minus 3, it is minus 2.5 or 2.59, so minus 2.6, let's say minus 2.6. And so you can see that our point is basically both negative, so which is minus 1.5 and minus 2.6. So after converting, we are getting this answer for Cartesian coordinate. So minus 360 polar coordinates is equivalent to the Cartesian coordinate of minus 1.5 minus 2.6. So from the initial drawing, we can feel that the graph is locating in the fourth quadrant, sorry, in the third quadrant, and that's what we got it now. So having this sort of idea is helping us to get the right answer. Sometimes students get confused when there's negative angle. So we will see some more example in future, and please subscribe my channel if you'd like to see more up-to-date videos.